So hey everyone, thanks for joining. My name is Tu, like Judith just mentioned, and today you're going to learn how to build and more importantly, customize your own Terraform provider. Like Judith mentioned, there are amazing TAs in the back. If you have any questions at all, raise your hand. They'll come around, ask the questions, or they'll help you with the questions. If they're a little bit more technical in nature, they'll probably ask you to bring it up here so everyone can benefit from the knowledge. Otherwise, if you have more instruct knowledge or instruct problems or challenges, they'll be around to help you through the hands-on lab portion. So the TAs, again, are Chris, George, and Ben in the back. Before we dive in, just as an extra incentive, if you complete the lab today, you can enter in a raffle to win a pro level exam. The steps are super simple. You finish the hands-on portion, you stay for the raffle. There's a short link that I will ask you to enter in your name, your email address, and which raffle you're interested in. And then I'll send you the email with the code and instructions if you win. That being said, let's jump into it. This workshop is broken into three main sections: a lecture, a hands-on lab, and a Q&A session. For the hands-on lab, we highly recommend you have your laptop and are running the lab with us. So behind your badge, you'll see your Wi-Fi password. I think this is a great time to just have your Wi-Fi connected to the internet. That way, when it's time for the hands-on lab, you guys are set to run everything. That being said, part of the lecture will be a bit of slides. It's not going to be super long, but I'm going to do a quick high-level intro to Terraform providers. Then I'm going to cover the lab scenario itself. After that, I'll show you how Terraform providers work under the hood. And finally, to cap the lecture portion, I'll go through the Terraform plugin framework. After that, we'll move on to the hands-on lab, where you'll add a new resource and a new data source into an existing provider during this section. This lab is supposed to take about 40 minutes. If we have a little bit more time, I might even show you how to update the provider and use our documentation and our tutorials to do the rest of this lab. And then at the very end, we'll have a very short Q&A session, but I will stop throughout the lab. If you have any questions, raise your hand, and I'll be more than happy to answer your question. So this is the Terraform workflow. I'm assuming most of you have already used Terraform before in the past, but just for folks who are unfamiliar with this workflow, first thing that you do is you write the Terraform configuration itself. After that, you run Terraform plan to view the proposed changes. And since we don't live in a make-believe world of diagrams, you'll most likely have to go back and fix the syntax errors and things like that. Once everything is good and you're happy with the changes, you run Terraform apply to provision and manage your infrastructure. And then after that, you may delete your resources, you may update them, but this is the general high-level overview of how to manage your infrastructure with Terraform itself. As most of you probably know, to manage the resources with Terraform, you need these things called providers. You need to install the right ones, and most of the time, the right versions too. Most of the folks are familiar with using Terraform providers for the large hyperscalers like AWS, Google Cloud, or Azure, but there are providers out there for anything. So for example, there is the GitHub Terraform provider that lets you manage things like your GitHub organization members and teams. You can use the console provider to manage a console cluster itself, or you can use the Vault provider to configure both a Vault cluster and populate it with secrets, or inject those secrets directly into Terraform so you can use it to configure other infrastructure. But then there's also like fun providers out there, right? Not super fun, but then if you've used Jira or Asana before, you can, I don't know why you would ever use Terraform to manage Jira tickets, but if you really want to, you can do that. If you were out in the Robo Rally, the dev advocate team created a custom provider to control robots. Judith wrote a really cool tutorial to make a Spotify playlist using Terraform, right? So basically anything with an API out there, you can write a Terraform provider for. That being said, we have this nifty website called the Terraform Registry. This has almost all of our official partner and community providers. And again, these cover a bunch of things. There are currently over 400 official and verified providers and over 5,000 community providers. So if you want to manage something with Terraform, it will likely be here. So why are you in this lab in the first place when there's so many providers out there? And the good answer for that is there's two main use cases in my experience with why you should either build or modify a Terraform provider. The first one is the most straightforward one. The provider simply doesn't exist. If you are running something for a large company, most likely there's some custom internal tools or some custom on-prem stuff that an internal tool built. It might have an API. You might want to start managing and codifying that with Terraform. So this is a very obvious use case on why you should build a brand new Terraform provider out there where something just doesn't exist. The other not super obvious use case, but one that I think is way more interesting is when you modify a Terraform provider, right? So at a company I worked for in the past, we had a bunch of VMware servers. Since it was a large healthcare insurance, there were a bunch of regulations, and then their security protocol had them configure the infrastructure slightly different than what the official VMware Terraform provider would do. So if they just pulled off the shelf, it just simply wouldn't work. So we went in, we modified it to authenticate with our protocols. That worked, and then because of that, we were able to start using a forked version of the VMware provider. And this is by and far the most common case, right? Where there is a provider out there, for example, like the AWS provider or something, they just released a brand new feature. The API is available, but the Terraform provider might not just be there yet. You can go out, if you really need the feature, create that resource, create that data source, use it right away until the next version of the Terraform provider comes out, and you can use it. So that being said, let's jump into the lab scenario. In this lab scenario, you're going to add a new resource type to an existing provider for an API called HashiCorp. HashiCorp is a fake coffee shop application that has a REST API. So this is the endpoints for HashiCorp itself. As you can see, there's authentication, which most APIs have. This lets you sign up and sign into the HashiCorp API. Once you're signed in, you can create a new HashiCorp order. You can also retrieve an order, update an order, and delete an order. Something that I haven't shown you here, but HashiCorp also support is you can also retrieve all the HashiCorp coffee. We have a bunch of coffees there, so we're going to write a data source to retrieve all those coffees. So this gives you an opportunity to both implement a data source and a resource, which is the bulk of a Terraform provider. At the very end of it, this is a sample Terraform configuration for what should work. At the very top, you'll see that we created the HashiCorp provider. We specified the provider here. It's just empty, but then I'll go through how the authentication works. And then at the very bottom, you'll see HashiCorp order. And this is how we define and specify a HashiCorp order in Terraform. As you can see in this, we are creating an order called edu, and we want 2 coffees of ID 3. So I'm going to do a deep dive into how Terraform providers work. I'm going to go back to this diagram. It shows that Terraform providers do the work of managing your infrastructure, but the Terraform core doesn't have any code in it that knows the difference between the different resources, right? So Terraform core itself doesn't know, or it doesn't super care if it is an AWS EC2 instance, an Azure function, or a Kubernetes job. All that is handled by the provider itself and the client libraries they use to call the target APIs. So what this means is whatever you think of as Terraform is Terraform core, which is the binary itself, and then also the providers, which implements things like resources and data sources. The providers expose the resource and data sources so you can define these in your configuration for Terraform to manage. So when you run the Terraform commands, Terraform core reads the configuration files, it parses it, and it builds a resource dependency graph. This is all that Terraform core does itself. The graph determines when Terraform needs to create, read, update, or delete a resource or a data source. When you define the provider that you want to use in your configuration, you install them with Terraform init. So once you do this, Terraform will pull down the providers, and the providers interact with a client library to manage the target API's resources, right? So part of this is you need to know that Terraform core is only parsing the configuration itself, while the provider does all the actual logic work. The other thing that you need to know here is the provider should not actually be interacting directly with the target API. We don't recommend that. We highly recommend providers to just have enough code to interact with the client library. The client library should be where all your logic exists to interact with the target API. The provider themselves, all it should be doing is similar to the Terraform core, where it parses the specific resource or data source schema for each resource or data source and takes that and converts that over to something that the client library will understand. I know this is still very abstract. When we implement it, it will make more sense. So Terraform core and providers interact with each other using a protocol called gRPC. Terraform core acts as the gRPC client and passes relevant parts of the parse configuration to the providers themselves. And then the Terraform providers act as gRPC servers and execute any domain-specific logic based on the parse configuration they receive. So in today's lab, your HCL configuration will define a HashiCorp order. When you apply the configuration, Terraform core will parse that HCL and make a call to the HashiCorp provider to create the order itself. The provider will parse the schema for the resource, send that information over to the client library, which interacts with the target API. Once that all happens, it will pass all the relevant information back to the provider, and that's where it will save the Terraform state. That is a lot of information on how Terraform providers work under the hood. Once you understand this, you'll be able to understand how Terraform providers and resources work together. And how you create Terraform providers is something called a plugin framework. So we have something called the Terraform plugin framework, which allows you to create a bunch of these providers. This is a series of different libraries called Terraform plugin mux and the core Terraform plugin framework. I will go into specifics on what each library does when we get to the hands-on portion. To use the plugin framework itself, we recommend you start with the official scaffolding repository. For this lab, though, we already checked out the scaffolding repository. We renamed it to HashiCorp. So we've done all the kind of hard part for you. And we've also implemented some things like authentication. I will cover how that works in this lab, but then all you will be doing in this lab is just implementing the resource and the data source. That being said, it's time for the hands-on lab portion. In this lab, we're going to start from the scaffold repo. We're going to configure the provider client. We're going to implement a resource, and we're going to implement a data source. For bonus, these are all the things that we have on our developer website, and these are guided tutorials that will teach you how to do the rest of custom provider development. Things like automatically generating documentation, implementing automated testing, and doing things like read-only values and ephemeral resources. So if you have your laptop out, please go to this link, hashi.co/custom provider lab. This should take you to a page similar to this. Once you see this page, click Show Terminal. This should appear, and then click Launch up here. What was it? So this is the URL. I'll keep it up before we do that. But please launch the terminal and click Start so we can move forward.
So basically, it's a split screen after that.
Yes. So once you launch it, it should be a split screen. The right side will have the instructions, and the left side will have the hosted terminal. On the left side, you should see a code editor and a terminal. For folks that are already seeing it, good. For folks that don't, let's wait another 2 minutes.
Yeah, my hamsters and robots are here.
Sounds good. So in the meantime, I know we covered a lot in the last 10, 15 minutes. Does anybody have any questions about provider development? Yeah. Yes, that's a really good question. You can use, so the question was, can you use RPC directly instead of Go? Yes, you theoretically can. We don't have a library for any other language. So if you do create one in Python or something like that, please open source it, and so other people can write Terraform providers in whatever language that you want. Cool. So does everybody already have this link on their laptop? Thumbs up? Cool. So I'm going to wait for another minute or so. In the meantime, while I wait, I'm going to just go over what this is. For this hands-on lab, please don't rush forward and just complete the assignment. This will be here on our dev website for quite a while. So the benefit of this being a hands-on lab is me and the TAs are in the back to help you answer any questions. So if you have any questions at any time, you don't get bonus points if you finish the fastest. That's not how we determine the raffle. So raise your hand if you have any questions, and we'll be more than happy to help you or route you to the right person to help you. So I'm going to resume this, and then let's wait a minute. Hamsters are still running.
Mine's locating the white rabbit.
Awesome. So when it works, you should see a start button, and you should see a split screen like this. On the left-hand side, there's a code editor, and then on the right side, there's the terminal. Here are all the instructions for it. If you get lost at any period, I would highly recommend you raise your hand and ask. If you are super stuck and you're behind, I would recommend just going to the progress button and skipping forward to wherever I'm at. Remember, the benefit here is to ask any questions that you may have and not to just complete this hands-on lab. So the first thing that you want to do is you want to verify that HashiCorp's API is actually up and running, right? So HashiCorp is running on localhost port 19090. So if you either copy this command and paste it over here and click enter, you should see the OK from the response. The other thing that you can do is just click run, and this will automatically run it if you're on the terminal screen. Did everybody do that? Cool. Next thing, now that we verified that HashiCorp is up, we're going to create a HashiCorp user. This is going to be super secure. The username is going to be education. The password is test123. So if you run that command, you should get a token back. What you're going to do now is you're going to copy the next command to export this as a HashiCorp token. So copy that over and then copy the token at the top and paste it in. And then what you want to do is you want to add it to the bash profile. So throughout the rest of this lab, you can still use it. Once you're done with that, please click check. And what we've done in this portion of the lab so far is we've verified that HashiCorp is running. We created a user, and everything is up and running. OK, so what I'm going to do now, if you're not caught up, it's fine. I'm just going to be covering some of the files. So if you open up main.go, you'll see that this is like the main place for where the provider is being called. The most important thing here is if you go down to lines 47, this is the address, hashicorp.com/edu/HashiCorp. If you remember this, this is where, if you look at the examples, that name or that address corresponds with this, right? So this is why that's important, and that's essentially the main thing that you would modify in the main function. Everything else is pretty standard and boilerplate. You shouldn't need to modify it, and that's the great thing about using the scaffolding repo. If you open up internal provider and then provider.go, this is where it implements the provider itself, right? Like I mentioned earlier, HashiCorp does have a login feature. We've already implemented the login feature for you, but this is how it works. The provider itself takes in a host, a username, and a password, right? And then from here, under configure, this configure function runs every single time. Yeah, so the HashiCorp's provider model, we define a host, a username, and a password. And this is what the client library expects from HashiCorp to even log in. So what we need to do now is just, if you scroll down to the massive code block, copy that over, scroll down to lines 53, and paste it into schema. And this is how we tell Terraform that, hey, this provider has these attributes themselves, right? So what we want to do is we want to map the client library over to the Terraform provider. And the provider level schema is we want to expose a HashiCorp API host, a HashiCorp username, and a HashiCorp password. These are stuff that we just created in the previous step. If you remember, the username was education, and the password was test123. The configure step is where most of the magic happens, right? So I'm going to go line by line. The configure step has 3 arguments. It has context, it has configure request, and it has configure requirements. Context is just part of the Go standard library. The request represents what Terraform sends to the provider. As I mentioned before, Terraform core is the gRPC client, and then the provider is the gRPC servers. So Terraform sends this information to the provider, and then the response is what the provider sends back sends back to Terraform from the provider itself. And this is where you would return things like error messages and warning messages. So the configure function does three main things, right? It will retrieve the provider data from the configuration, and this is, it gets it from Terraform core. It validates that the username and password and host are configured, and then it creates a new API client and makes it available for the resources and data sources. So that's here. If you look at the code itself, lines 79 is where it retrieves it from Terraform core. Afterwards, it will check to see, hey, is the host unknown? If it is unknown, if you didn't specify it, return with this error message. Is the username unknown? If it is unknown, return it with this error message. Same thing with the password. The other thing that's important here is for provider level stuff, we also want to retrieve all these information as environment variables, because environment variables are a safer way to pass sensitive credentials into the provider itself. That way you're not hard coding credentials into the configuration. If you remember in the previous assignment, after you created the HashiCorp's username, you exported it as an environment variable. And this is how Terraform knows to authenticate to HashiCorp's. Again, if host username and password is no, set it as the username. This just shows that it's missing a username. If it is, then throw an error because the API client expects that. And what we do here is we just Terraform log the host username and password just for debugging. And then at the very bottom on lines 183, we create a new HashiCorp's client. As you can see, we set this to client. And then down here on lines 196 and 197, we add the client to the response for the provider. And this is how both the data source and the resource will be able to retrieve this client.
Would the action be a third one for providers then?
Excuse me?
Actions?
Uh,
Will they be here that in like lines 197 or after 198?
Yes, so that's a really good question because the plugin framework is our latest and greatest version of how to create providers. So all the new features for Terraform will eventually show up in the plugin framework. So if you keep your eyes out in the next couple of months, there should be another function for actions or something like that, where like resources and data sources are right now. That being said, this is an example HashiCorp's configuration for that. We specified username, password, and host. We really don't recommend you putting this in your Terraform configuration because you're hard coding your credentials. This is why we implemented retrieving the host username and password as environment variables. Next thing that we are going to do is we're going to add the resource to the provider. So if you scroll to the bottom of this file, copy this code snippet and just paste it in. As you can see, the only thing that we are doing here is we're adding new order resource into this resource.resource structure. So if you are implementing another resource, you would just say new order to resource. And this is how you would add new resources or data sources or whatever attribute there is. So if you click check, it will just verify that you've set everything up correctly. Now we are going to define the order schema because we've already added that into the provider. So the provider is expecting something to be implemented in order. So if you open up internal providers and then order resource, this is everything that the client library expects, right? So part of order, an order has an ID, it has items, and then it also has something called last updated. And this is a special thing that HashiCorp itself doesn't have, but we added it. So when you do update a HashiCorp resource, you can see that there's some modification. Within the items themselves, we are specifying a coffee and a quantity. So if you look at order resource model under items, it specifies an order item model, and then order item model has coffee and quantities. If you look at coffees themselves, you'll see that it's also a structure with an ID, a name, a teaser, a description, a price, and an image. And if you look at the order resource, you'll see that it contains a client, and this is how we are going to interact with the HashiCorp client itself. Another thing that I want to call out is this metadata, and this is how Terraform recognizes that this is a resource. If you go into examples and then orders, you'll see that this is HashiCorp_orders. In metadata, this is how it's specified, right? This is the resource saying that provider type name is HashiCorp and it's _order. So if you modify this, this is what the resource name would be called. What I'm going to do now is I am going to define the order schema. So I'm just going to copy all of this, and then on lines 56 to 61, I'm going to highlight that and paste that in. The other thing that I'm going to do is I skip this one command. So in the terminal, I am going to just run this curl command, and this creates a coffee order. As you can see in the curl, I passed it a coffee with ID 1 and quantity 4, and another coffee with ID 3 and quantity 3, and this is the response it came back with. The order ID is 1, and it contains all this information, right? So what we want to do is whatever the HashiCorp's API and client library expects, we need to define it in a way that Terraform expects. So in schema, that's how you would define it. So for a order resource, we are creating a description. This resource manages an order. We have an ID, and this is a computed value. Computed just means that this is something that the API will return, and it's not something that the user provides. And then we also have last updated. This is also computed, so this is something that the resource defines. It's not something the user provides. Under items, we are making it a required field because to create an order, you must have a list of items that you want. First thing that we have is the quantity. Again, this is required, and this is how many coffees you want in that order. Then you have the coffee items, right? And the coffee is, if you look over here, a object. So an object with an ID and a bunch of attributes. So for each one of these, you have to define it. So for example, an ID is an integer, and it is required. A name is a string. Teaser is a string, so on and so forth. So for each one of the things that the client library and the API specs, you have to define it in the schema because the schema is how Terraform understands it. Next up, you will, I guess this is all we are going to do in defining an order schema. So you will click check and then move on to the next step. Am I moving too fast? Is this pace okay? Cool. So I am going to implement create and read. So after you have defined your schema, now you can actually create the resource and configure it. So first thing that you want to do is update the configure function itself. So at the very bottom of order resource, lines 134 to 137, highlight the 4 lines and replace it. What you are doing here is you are retrieving the HashiCorp client from the provider data. This is where you specified it in providers.go before on lines 197 right here. This is how you are retrieving the configure HashiCorp's API client. If you can't do that, Terraform will return an error, and this is how you define that. And if there is no error, you just set the client to something that the resource can actually retrieve later on. Next thing that you will do is implement the create function. The create function does like these 6 steps, right? It checks to see whether the provider and API clients are configured. This is required because the resource needs the API client to actually interact with the API. It retrieves the values from the plan, and then all these values are defined in the schema themselves. It generates the API request body from the plan values. Afterwards, it creates a new order from the API request body. It maps it to the resource schema, and then it sets the state to the new order. So this is the entire code to implement all 6 steps. I'm going to copy it in and replace it in the create function, and we can go through this line by line. So on lines 118, just copy and paste that entire code snippet in, and then I can go through it. So number 1 checks whether the provider and API client are configured. As you can see here, in configure, we already checked to see if the API client is configured. Configure always runs first, so that checks off step number 1. Step number 2 is retrieve the values from the plan. As you can see on lines 122, it retrieves the plan from the provider itself. Remember, request right here is from Terraform core. From there, it will map the items in the plan over to something that Terraform or that the API client will actually understand. So what you see here is this is the plan that we retrieved from Terraform. We are iterating through each one of the plan items, and then we are creating the API request body in a structure that the client library understands. Once we create that in this value called items, we are creating the new order using the API client. So if you run this, it creates the API client, makes a call to the API itself. This passes the values into an item called orders. From orders, this is the most important thing. It maps it back into Terraform as a state. For resources itself, you need to set a plan.id. If you do not set an ID, Terraform will not save the state file, right? So for every single create function, you need to set an ID. This is a very common issue for provider development. But then everything else is pretty straightforward. Once you retrieve the order, you iterate through it, and you map the item back into the schema that we provided above. From there, the last thing that we are doing is we are just updating this last updated value to the current time. And then once we have that, we just set the state using response.state.set, and this lets you just set the state for this one resource. Does anybody have any questions before we move on? I know that was a lot. Cool. So the great thing is create and read are almost exactly the same. The only difference between create and read again is in create, you need to set the ID. In read, you don't need to set the ID. So the steps for a read function is you retrieve the current state, you retrieve the order ID from the state. This is why we created and set that order ID in the first place. You take that order ID, you call the API client to retrieve all the information, and like before, you map the response body back into a structure that Terraform understands, which you defined in the schema. So copy this code snippet, and wherever it said read, replace the entire thing. And I'll go through things line by line. So the first thing is you retrieve the current state. You see this on lines 178, where you're retrieving the entire state. What you're doing here is in state itself, you are retrieving the ID as a string, because this is what the client, this is what the API client expects. And then once you have that order ID, you are using the API library to retrieve that order and mapping it into order here. Just like the create function, what you're doing is once you have that, you iterate through and you map it back into the schema. And then at the very end, you set it and overwrite the previous state. And last but not least, we are using a bunch of different Terraform plugin framework libraries. So far what we've used is the resource type, the resource schema type, and then the types type. So just so we don't have any errors, just copy the imports and replace it at the top. We also use plan modifiers, string plan modifiers to implement everything else. So once you're done with this, you can click check, and then in the next step, I believe we are actually going to build the provider and test things out. So I am going to run this command to show what is in terraform.rc, but I will return to explain what this is in a bit. But as soon as you're done with that, please run go mod vendor, which goes and installs all the dependencies for the provider itself, format all your provider code, and then at the very end, run go install. Go install will take a while, so this is why I wanted you to just blast through and run go install before we explain what terraform.rc is. In terraform.rc, you can set overrides for your providers themselves. This is super important for provider development. If you remember, the Terraform provider that we are using, the address was hashicorp.com/education/HashiCups. But instead of going out there and retrieving that value from the Terraform registry, what it's going to do instead is it's going to look into the Go bin, right? And this is where we're building our Terraform provider. The reason why this is important is when you have this, it just overrides all the Terraform init stuff for the custom provider that you're working on. So let's say you're developing the provider and then you want to actually use it or use a different version of the provider in your configuration, in another configuration. this Terraform.rc file will overwrite that and just pull the local version instead of using the Terraform registry. So if you're developing Terraform providers and are saying hey, why is this slightly different? First thing I would do is check the .terraform.rc file just to make sure that you are pointed to the right provider. Once everyone is done with the go install, this means that the provider installed everything. So if we click check, we should be able to actually use the provider to test the configuration itself. So I am going to start here. I'm going to show you what is in the examples before we actually create it. So in the code editor, examples, orders, and main.tf, as you can see here, at the top, we are defining the custom provider that we created. In providers itself, this is super insecure. What we should have done instead is we should have created environment variables because we don't want to hard code credentials on here. But as you can see, the host is the HashiCorp's API that you verified in the very first step. The username is education, password is test123, everything that you created in the very first step. We are creating a new order where there are 2 items, a coffee of ID, 3, 2 of those, and then a second coffee with ID 2, we want 3 of those too. And then we want to just view what the coffee order is. So in your terminal, navigate to the orders example, then run Terraform apply. And then at the end, just enter yes to confirm everything. As you can see here, in the plan, it says that we are creating a new resource called HashiCorp's order with the name of edu. The ID is unknown because it's computed. And then the only thing that we provided to Terraform was the ID and the quantity. So everything else is known after apply, which is something that we expect. And then also last updated, which was a computed value, is known after apply. And after you ran Terraform apply, this is what it shows, right? So you can see that there is an order ID of 2. So you can verify this is the newly created order. There's 2 coffees of ID 3 and 3 coffees of ID 2. And the last updated value shows the time about a minute ago. So you can verify that this is working by running this curl command and verifying that this order and this order are exactly the same. So I'm going to click next, and then now that we've done create and read, I'm going to just implement a data source. So for the resource itself, it was an order resource. Now what we're going to do is we are going to implement the coffee's data source, which pulls all the coffee information. So if you open up internals, providers, and coffee data source, scroll to the bottom in configure, copy this and just replace it. This should look very, very similar to the resource configure function, right? What you're doing is you are seeing if the provider is even returning anything. If it isn't returning anything, there's probably an error. You are trying to retrieve the HashiCorp's API client from the provider itself. If there is no client, it should return an error. If there is a client, set it as part of the data source itself so everything else can pull from it. So the steps to generally create a resource or a data source would be configure, then the schema, then the read or create function, right? So now that we've done configure, let's update the schema itself. So I'm going to copy the entire schema function and replace it with this. And very, very similar to the order resource. I'm not going to cover it that much. This fetches a list of coffees. Within coffees itself, it's a list of attributes. Each coffee has an ID, a name, a teaser, a description, price, images, and ingredients. Ingredients is actually a nested list too. So within ingredients, we have a bunch of IDs, right? So this should return a list of IDs. So now that we've defined the schema, we can define the read function. So copy that code snippet and replace the read function itself. And this should be very, very similar to the order the order resource read function. Resources and data sources are almost exactly the same. The main difference is that data sources only implement read, right? So for data sources, you don't need to implement create. So you also don't need to worry about setting the ID. So I'm going to go through the read function line by line. Similar to the resource one, first thing it runs is configure just to check if the API client is there. If it isn't there, it will error out. If it is there, it will proceed. Because there is nothing for us to retrieve from the schema itself, because it's just retrieving all the coffees. What it's doing is it is just running this API client to retrieve all the coffees. If you are using a data source that requires some attributes to retrieve it, you would use request dot whatever to pull in the plan to get that attribute, and then you would pass that attribute into the client library itself. But in this case, since we're retrieving all the coffees and we don't really care about a specific coffee, we can just run this function. If there's an error, it will return an error and then stop there. Otherwise, it will iterate through all the coffees, map it from the API client libraries type over to something that Terraform would understand and something that we defined in the schema itself. And then afterwards, we just set the state. If you notice here, we didn't set an ID for the overall data source, right? And that's what really makes data source and resource different. Resource, you have to implement the create function. Data source, you don't need to implement the create function. Create function, the main thing that you need to do above all else is to set the ID. If you don't set the ID, nothing will actually be saved in state. Even if you set it in state here. That's one of the things that while developing providers, it kept tripping me up. Last but not least, we are going to update the imports. So at the very top, copy and paste everything. And even though we implemented the coffee data source here, what we still need to do is go into the provider.go file, scroll down to where it says data sources, and add the new coffee data sources. So on lines 202 for provider.go, just copy this over and replace the entire previous data source function. Once you're done with that, go over to terminal. You would want to format your code, then run go install. If you notice, this go install will be much, much faster than the first one, because the first one, it's still compiling everything. And then let's test it out. Before I test it out, I'm going to go over to examples, into coffees, and just check out what this actually shows, right? So the top is exactly the same. For data source, we are using a HashiCorp coffees data source, and we're passing no attributes to it, which is what we expect. And then the output should just show all the HashiCorp coffees. So in terminal, I am going to navigate to the coffees example, run a Terraform apply, and then confirm that apply with a yes. And as you can see in the output, it shows the coffee's data source. For each coffee, it shows an ID, an image, a list of ingredients. It doesn't actually show the ingredients names because we didn't define that in the schema itself. But then from here, you can see we have a bunch of coffees from HashiCups. We can also review the state by using Terraform show. If you want to view the state without actually running Terraform apply, or if you close this session and you just want to view the Terraform state. Last but not least, we are going to implement the delete function in the orders resource. So this is going to be pretty straightforward. If you open up internals, providers, and go back to the order resource, what will happen is you will scroll down until you find the delete function, right? So if you copy this and paste it in there, I will go through the steps or go through each line by line. What we're doing is we are retrieving the entire state from the Terraform provider. We are retrieving the ID of that order from the state itself. And then we are just calling the delete order command. If there is nothing, if we return nothing in the delete function, it just assumes that the resource automatically deletes. If, for example, we return with an error, it will cancel out the delete. So this is just something to keep in mind. So if you go back into the terminal, format your code, rebuild the provider, now we can test it out. So we will go to the orders example and then run a Terraform destroy. As you can see over here, this is an order ID of 2, and we are destroying it. Confirm it with a yes, and there are no more orders. So if you run a Terraform state list, it should show no state. So the other thing that we can do is curl command. What we can do here is I am going to just run it on my command or my terminal. This curl command, this is doing a get request to localhost 19090, which is HashiCups. If you check what order number 2 is, this should return an empty object, which confirms that even in HashiCups, there's no more orders left. This concludes the hands-on portion of the lab, but then there's still one huge section of this resource that we still haven't updated, which is the update function, right? And this is a good transition to like all of our other tutorials. If you go to developer.hashicorp.com, scroll down to Terraform, tutorials, and on the left side, there is custom framework providers. We have the rest of this. We have resources to guide you through creating a custom Terraform provider, right? So things I mentioned before, like implementing logging, creating automatic testing, generating documentation, all that fun stuff, in addition to like implementing imports. What is most interesting here is there's a tutorial for how to implement update. So this is built on top of HashiCups. So what I'm going to do here is I am just going to copy this update function and paste it over to this. And I can go through what this actually does. It's very, very similar to the create function. The only thing that we are doing is we are retrieving the order ID in the very beginning. So first thing that we do, we check if the API client or is available. You do that in the configure function. Next up, on lines 2 to 6, we are retrieving the order ID from the plan. And then we are generating the API request from the plan itself, because there have been modifications to the plans. And then we call the update order. So what we're passing here is the order ID and then the new HashiCorp items. Once we do that, so depending on your client library, this will return either the updated order, or what we've done, just so it makes more sense, is we take the order ID and then we retrieve a brand new response from the order itself, just to verify that this is pulling from the latest and greatest HashiCorp version. Once we get that, we map it back into the schema. We update last updated to the new values, and then we set the state. So to see this in action, you go to examples, orders, main.tf. I'm going to run Terraform apply again, because we destroyed this previously. So this is creating an order number 3. So there's two coffees number 3 and 3 coffees number 2. What I'm going to do instead is I'm going to update this to 30 coffee number 2s and 20 coffees number 3s. It's going to save, and I'm going to run Terraform apply again. And then as you can see, even though the order stays the same, the quantity goes from 2 to 20, and then from 3 to 30. And then last updated also gets updated. So if I confirm with a yes, this produces an error. The reason why this produces an error is we didn't go back and install the new provider version. So I'm going to format it again, go to go install, and this downloads the new provider version. Go back to examples order, and then run Terraform apply. That's how you know this is a live lab and it's not recorded. So now that I have confirmed it with a yes, you can see that, yes, it is showing that we have 20 coffee number 3s and 30 coffees number 2. So we confirmed that the update function works in HashiCorp. So far in this lab, what you've done is you've implemented a brand new resource. You implemented create and read and delete. You saw me do update. I gave you the resources to show you how to do other things in resources, things like import. Import is super cool because all you need to do is just copy this one function in, and it will just automatically work, right? And honestly, this custom framework provider collection of tutorials is amazing. And things like write-only and ephemeral resources and possibly actions will be here as soon as we create the content for it. And then it also has things like publishing it to Terraform registry. So as you are creating all these custom Terraform providers, it will also guide you to release and publish them to the registry so other folks in the community or other folks in your company can start to use them. So that is the hands-on lab sections. This is the short link to the tutorial collection that I just showed you. Otherwise, you can go to developer.hashicorp.com, go to Terraform tutorials, scroll down to custom Terraform providers, and all the content is there for you. Does anybody have any questions before we wrap this up? Cool.
Thank you, too. That was beautiful.